So I said I was going to make a video on using your calculator to do the iteration, and I just want to look back at how the ClassWiz calculator did it to make links to how you can take advantage of the CG50. So on the ClassWiz, let's say my function was just 2x plus 3, and I'm going to have my first term that goes into this function to produce first three terms is going to be 10. So here in your calculator, you know you can press 10, press the equals button, and that goes into the ANS button, and you can write it out in your calculator as then 2 ANS plus 3, and then you can just keep pressing the equals to get your x1, your x2, x3, and that actually can be replicated quite well on this calculator as well. So if I was to write 10 equals then 2 shift ANS plus 3, I press equals once, x1 is going to be 23, press it again, 49, press it again, 101, nice and easy. Now this could have also be done for this. So we've got a quadratic here, and it can be written in our iterative form here, recognizing this is going to be my input and this is going to be what I get out for my next instance, which is going to be my next input here. And they show it further in the question here as xn and xn plus 1 for the subsequent instance. So this could have been done also on the ClassWiz or this calculator using the ANS button, where in this case you'd be writing in 4 minus 1 over ANS and then pressing equals in the very same way, and your answers would follow in the same way here. Let's say you're given a starting value of 3. Let's see what happened here. So you'd have, let's say 3 is going to be starting value, so I'm going to press 3 and then execute for equals. Now that's in the ANS button. I can say 4 minus 1 over shift ANS. Now I can say, all right, here the first value out is approximately 3.6.6. Press equals again in decimal form. It's 3.727 going on. Press equals again. So this is x1, x2, x3. Here 3.7317, and so on and so forth. So that's all in the realm of what we already know how to do. To use the calculator, you would go to menu and then recursion, which is menu 8. And then here, it looks very similar. You've got AN here, but this is really your output for the next input of your variable. So AN, you're going to recognize is going to be the X you're going to be putting in. And AN plus 1 is the next instance for your output. So let's put in a function again. So it's going to be 4 minus 1 over. And now here in my tabs here, F2 is going to be my AN. So now it's now set up. So this is going to be the instance I'm wanting, the variable for that instance, and then the output that I get from that instance, the subsequent or the next instance. All right. So then if I press execute, and then I'll go to set. Now a few things can be done here with set. First of all, I have my start and end. This is how many terms I want. Currently set up to start the first term and end at the 10th term. I can start the third term and go up to the 15th if I want to, but here first 10th. Let's go a little bit further. Let's go first to 20th term here. Now you've also got AO, BO, and CO here. Now this is, again, we're just worried about A now. You are going to be thinking about whether you want to start with your X1 or X0. Here you can have A0, A1. This will just be in your table whether you want the first output in your table to be the first output after you put in X0, or you can have the first output being the value you're starting with, X0. I'm going to say I want my X0 to match my A0 here. So I'm going to put 3 here as my starting value, and I'm going to use A0, and then my table should give me my first output as this value here given here. So if I was to go down a little bit more, I can also recognize I've got this ANSTR. Now this is for the graph. For graphing, you can actually see the staircase or cobweb diagram with this and you just have the starting point. So remember, different starting points might diverge or converge depending on the graph, but you actually can draw the graph against the line of y is equal to x and give it a starting point. I'm going to give it a different starting point. I'm going to say, let's see what happens if you start with a starting point of 1, and we'll see that in a second. So press execute, come out here, then I'll go to table. Now I can see, just as I said, for my first import 3, my first output, these are the same values that we got here. I only did the first 3, but if I wanted to and look at them more carefully, I can hover over them and see what they are in decimals, and I can go all the way down, because I went all the way up to the 20th term. So that's nice and easy, and I can get them, and it saves a lot of time, and you can see exactly when the decimal places aren't changing very, very quickly. You can also have a quick look at the sketch. Here on F4, it says web graph. If you click on that, you can actually see the graph it creates along with the line y is equal to x. You can zoom in a little bit first. So I'll just press plus to zoom in. And now if I press execute, I have this little mark here which is at 1, because I chose that as a starting point for my iteration. And if I press, every time I press execute, it's actually doing, I'm not sure if you can see that, this staircasing towards the point, and you can see the coordinates of the points here. So that will take you very, very close to the given root. So that will be a way you can both see the graph, the staircase, or the cobweb diagram, whichever it creates. And if you come out again, you can see the table as well. So you've got access to both those, and you get the whole sequence out without having to do it one at a time, or without having to use the ANS button.